Well, welcome to this next lesson using the ESP32, and today we're going to be looking at how to connect it to an I2C 1602A liquid crystal display. So moving over to the workbench, here is my display hard at work, and the display that we're looking at is this version with the I2C backpack. Now, there is another version, the basic version, that doesn't have this unit, and instead you use these different connectors on the edge. The big difference is this requires 4 pins, 4 connections. This requires a whole load of them. So these are a much better board to use, and that is the board that I will be concentrating on for today's tutorial. Now, as always, there is a link to the Digital Town site, and if you click on that link, it will take you over to the resource page to do with this lesson. Now, once you've clicked on that link, it takes you over to this page. Obviously, we've got the video, we've got the code for today's video. I've got a link to an ESP32 pinout diagram. And we've got the circuit diagram. There is one other link here, and this will take you over to a video, and that is lesson 17 in the Arduino course. Now, the reason for taking you over to this is that the code for today is taken from lesson 17. There's basically no differences. The big difference is in the circuit diagram. So if I just click on this one here, you can see that the Arduino is connected directly to the LCD display. Now, the reason for this is that the Arduino is a 5-volt board and the display is also 5 volts. Now, this causes a slight problem when we come to the ESP32. So clicking on the circuit diagram here, you can see we've got our 5-volt display. Now, there's nothing I can do about the board being a 5-volt display. If you feed this display with 3.3 volts, the display won't light up. The logic will run, but the display won't run. Now, there is a way that you can butcher the connections and have 5 volts to the screen and 3.3 volts to the logic, but I am not going to do that. Life is too short. So instead, we're going to use a logic level shifter. Now, just clicking on the first link on eBay that came up, here is actually the version that I'm actually using. Now, the way these work, you have a L level, a sort of a low level, and you've got a high level. You've got 4 pins or signals that are to go through. You then have a high level voltage and a ground, and the low level voltage and the ground. So in our circuit, coming back to the page, we're only using 2 pins, and then we've got 5 volts. Now, this is coming from this external power supply. Technically, you could possibly use the VIN pin if you're supplying your ESP32 with 5 volts. But in the way I tend to work on a project is the board will be receiving 5 volts from somewhere. So I will tend to take the same power supply that will be going to my project. I would send that to the screen. However, because in these examples I'm using my USB supply, I'm going to be using a separate power supply for the LCD display, and it's a good habit to get into. Now, the reason for needing this sort of bidirectional level shifter is that with an I2C signal, which is what we're using here through the wire system, I need to be able to send commands to the display, but at the same time, the display also sends information back. Now, the logic of the board here would be quite happy receiving 3.3 volts, not going to cause any problems at all. The problem is with the response from this board sending it back to the ESP32, because this is now set at a 5-volt level. If the 5 volts were to come back without the logic level shifter, then we're going to put 5 volts to an input pin, and that's going to be a very bad day for the ESP32. it's probably going to let the smoke out. So that is why we have to have this logic level shifter to keep the 3.3 volts and the 5 volts separate. Now, apart from that, the using of the board remains basically the same. So let's get over to some code. So this first sketch is going to be based on sketch 1 from level 17, and I've left the connections in for the Arduino here. Now I have also put in the connections to the ESP32. Now the first issue that you're going to have with an ESP32 is what pins are the SCL and the SDA on. So looking at this pinout diagram of the ESP32 dev module, you can see that I have an SCL up here on pin 22, and then the SDA is on pin 21. Now this is where things can get a little bit confusing. If we go back to the webcam, you can see that here I have an ESP32, I think that is a C3, and that's a Super Mini. We've got a C3 WEACT, I think it is, and this is the ESP32 S3. Now all of these boards have a different pinout for the SDA and the SCL. So unlike the previous board, you can see that the SDA and the SCL on the C3 and in fact on the S3 as well are both using pins 8 and 9 by default. Now it is possible to change the pins that you use, but let's keep things easy and we'll stick to the default pins for now. Once you've found the correct pins, then it's just a case of connecting up the appropriate connections here to make sure that it runs through to the correct pins on the screen. Now the first thing we need to do is find out the address of the board. Now by default, I think from what I can remember, they have a hex value of 27 by default. But you will see here that I have soldered over the little connector between A1. So you've got A0, A1 and A2. And by putting solder blobs over these, you can change the address of the board. Now the reason I've changed the address of this board and this board is it comes from a bigger project where I had 4 of these screens running together. So each screen needs a separate address. So the first thing I need to do is find the address of this particular board. So to find the address, just go over to File, Examples, scroll down until you get to Wire, and then go into Wire Scan, and that will bring up this sketch here. Now, we're not going to learn much about this sketch. We're just going to check the serial begin. There we are. It's running at 115200. So I'm just going to upload this sketch. As you can see, once that sketch is uploaded, it looks for I2C devices. And you can see that my desktop one, the one that's attached to the project, actually has a hex address of 26. As I've said before, by default, it's usually 27, but because I've soldered across a tab, I have changed the address to 26. So now when you come over to the first example sketch, if you're using the default address, that is the line that would need to be uncommented. So you're going to have a 2-row 16 element display on address 27. Obviously for my particular sketch, I don't have that, so I am using address 26 instead. Once you've got your address, then there are some other examples of how to use the library. Again, that is from the lesson 17 of the Arduino course, so I'm not going to go into that today. We've got the serial begin, and it's going to serial print out the file details. sets up the screen, turns on the backlight, sets the cursor, and we're just going to print out hello world on the top line, and the second line we're just going to send second line to position 4. So let's just get that one uploaded. Now what I'm going to do is just show you this uploading, because you'll notice a warning comes out here about the I2C liquid crystal library, and it basically says that this may be incompatible with the board that we are using. Let's just scroll back up, and there we are. So I2C claims to run on AVR architectures and may be incompatible with your current board, which runs on ESP32 architecture. Now, the first thing to say is don't panic, because as you can see, as I bring the desktop over, you can see that it has worked absolutely perfectly. Now, the reason for this is that when the I2C library was last updated, which I think is about 7 or 8 years ago, the ESP32 was virtually just coming out. So obviously it wasn't updated, but it does run on the ESP8266. And it seems to run on the ESP32 no problem. I've had no problem with any of my projects, and obviously this is a warning rather than a compiler error, but it's important that you see that, just so that when it happens, don't panic, nothing's gone wrong. Now once that sketch is running, all I've then done is gone over to sketch 5 from lesson 17. I'm not going to go through the whole lesson. The main thing about today's example was just to show how to connect the liquid crystal display to the ESP32 and just highlight the need for the level shifter and the slightly different circuit. This one is the one that does the binary counter, and if you go over to lesson 17, there is a progression of how to get through to this counter, because this version, the reason I wanted to show this sketch is it uses string padding to make the lines look really nice in the display. But from a programming point of view, the main difference is obviously the connections are different, and the only other change I have made is in the setup with the serial begin and the serial print. And to be honest, you could just run the other sketches from the original lesson, running them at a baud rate of 9600, and they're going to work fine on your ESP32. So if you want to learn more how to code and use this LCD display, then go back to lesson 17. There is the link there to the lessons page, so that you can learn how to actually use the unit. Now once again, as I've uploaded this sketch, once again that error from or that warning from the library has appeared, but don't panic. As you can see, the display is working really nicely, and if we look now as it comes up here to the rollover, you can see that we're getting that nice string padding effect where the numbers all stay fully right aligned. So that's going to be it for today's video. This was a sort of request from someone who wanted to use one of these screens with the NowRail system. So if you've got any particular requests on projects that you want some help with, just send me an email and I'll see what I can do. Right, well, I've now got to get this integrated into the bigger project on the NowRail system, so I'm going to get started on that. Again, if you've got any requests, please just let me know, and if you'd like to help the channel, please click the like and subscribe. So thanks for watching, and I'll see you in the next video. Bye for now.